Welcome. Thank you so much for coming this afternoon. This is a TESS talk, which stands for Together Embracing Successful Scholars. And the purpose is to feature really fantastic women scholars at Auburn University. And this event was put on by the Women in Science and Engineering, the Office of Inclusion and Diversity, and the Women's Initiative. And I'm Heidi Close, and I'm the chair of the Women in Science and Engineering. So let me introduce Haruka Wada. Haruka got her Bachelor of Science in Zoology at the University of Washington and got her PhD in Ecology and Evolution and Behavior at the University of Texas at Austin. After doing a 2-year postdoc position at Virginia Tech and the University of Western Ontario, she joined the Department of Biological Sciences here at Auburn. Her lab studies stress physiology, and she was recently awarded an NSF career grant to investigate the relationship between organismal and cellular stress responses. So very cool.
All right. Let me start my talk by asking you a question. How many of you feel under stress lately? Yes? How would you rate your stress? Mild? Moderate? Severe? Okay. All right, well, this would be a good audience to give my talk to. So this is obviously the person who's under a lot of stress. So just like we are under stress, a lot of the animals in the wild are also under stress. And that range from severe weather to food shortage to predation. And my research focuses on how animals are affected by stress, how they respond to and adapt to stress at a physiological level. As an undergraduate student, I was fortunate to go to Alaska to catch birds. And Alaska was truly an amazing place. I saw great scenery and also amazing animals like the mother moose and a calf crossing the road that we were driving. We also got to visit a snowy owl nest, like an owl that you see in Harry Potter series. And they have a really cool nest. They nest on a mound. They have a nestling in the middle. And the parents line the nestlings with prey items so that they can feed. And of course, well, we found that one of our study species in among one of the prey that the parents were about to feed. So that shows that, of course, my birds, just like others, are faced with predation stress. We also saw some of our birds experiencing severe weather. So one early spring storm hit and snow dumped on all of our study area. And we saw some females that were kept on incubating under the snow and didn't want to leave, whereas some other females could not take the weather and decided to leave, abandoning its nest. As we were watching this decision making, right, the females making decision whether to stay or not, and physiological mechanism that must have dictated that decision, I started to wonder, what's going on inside the nest? How about young? How about eggs? They are shielded from the weather by parents, yes, but the parents are not there 100% of the time. They have to go out and feed. When they do and they leave the nest, even though short period of time, they are exposed to thermal stress. If they're young, then there also can be hunger that's associated with parents leaving. So I started to wonder, do they respond to stressor or environmental change? And when do they start responding to a stressor? So I asked one of my research mentors, do young birds, nestlings, respond to a stressor and mount a stress response? And the answer I got was, I don't think so. So, well, it's true that the nestlings that I'm talking about is no ducks or chickens. The nestlings that I was interested in was sparrow nestlings. So they hatch at a very early developmental state. And when they hatch from the egg, they cannot thermoregulate, their eyes are shut, and they're 100% dependent on the parents for feeding and keeping them warm. But they also go through tremendous development during the nestling period. So this is the same individual, white-ground sparrows, going from day 2 to day 9. So within about 10 days, they go through this amazing development. They go from little white ball of flesh to really alert-looking individual. And soon after they leave the nest, they're on their own. They face very similar stressor as the parents do. So I kept on wondering and actually dug around the literature, and I found nothing. All the literature that I can find was focused on adults, how adults respond to stress, how their stress responses are like, but nobody was explaining or describing the stress response in young nestlings. So that was a pivotal moment for me because I kept on wondering, and that set the course of my research for the next 6 years. So as a first project of my dissertation, I asked this question: how does the stress response change with age within this nesting period? So I went out to the field, searched for nests for hours and hours, and when I found the nest and got the nestlings, I blooded them, and then I put them in a bag, held them for half an hour, and half an hour later I took the blood sample again. And they perceive this, me as a potential predator, being held as a stressful situation, and they start to secrete hormone called corticosterone. And the difference in the levels of corticosterone, just as I grab them and 30 minutes later, the difference is what I call here a hormonal stress response. So again, this 10-day nesting period, during this time, they increase body mass about 800%. And yeah, I say the same thing too. And they also increase the stress response about over 700%. Yet, the stress response of the nestlings right before they fledge, about this guy, was not as high as those of adults. So what's going on? So as I was telling you before, the nestlings that as I catch them, they perceive me being held as a stressful situation. They secrete corticosterone. You can also directly provoke the stress response by injecting a stimulating hormone called ACTH. And this can bypass the perception of stressful situation by the brain. So when I directly injected these nestlings with the ACTH, the nestlings that are really about to fledge can mount a corticosterone response just as the adults can. So in other words, nestlings' adrenals, by the time they leave the nest, are capable of secreting corticosterone just like adults. But there are some mechanisms that prohibiting them from doing so when I just catch them and put them and hold them for 30 minutes. When I was searching for nests and monitoring nests on the Sierra Nevada mountains and coast of California, I noticed something. There are some females that sit on the nest so tight that I literally had to lift her up to check underneath her. Does she have eggs? Does she have nestlings? And some females, other females, saw me from a distance. They take off and don't come back for hours. So there is a personality difference, or just like we see in us too. So I started to wonder, how does the maternal or parental incubation behavior affect offspring? When parents sit on the nest really tight, they can keep the nest temperature, therefore egg temperature, very consistent and at or near optimal temperature for fetal development. If the eggs are neglected, then the temperature of the nest and eggs can be more variable, and it can be too low or too high for the fetal development. So in another word, parental behavior, incubation behavior, govern the nest temperature and egg temperature. So that led me to a project I did as a postdoc. After 5 years of searching for nests and crying over the failed nests, actually about 70% of my nests that I was monitoring failed, mostly because of predation before I could collect anything. So after doing that, it was great, but I decided to do this project with a captive zebra finches. So I took their nest and I took their eggs and divided it into 3 different temperature groups. One is at their optimal temperature for development. The other one is at 1 degree Celsius lower, and the other one is 1 Celsius degree higher than optimal. So this 1 degree Celsius or 2 degrees Fahrenheit higher than optimal was high enough to decrease hatching success and also body mass and lean mass. And lean mass I mean here is tissue and muscle mass. Also, being cold wasn't great either. So 1 degree Celsius or 2 degrees Fahrenheit too low or lower than optimal was low enough to decrease nestling survival. So yes, incubation temperature or nest temperature that's governed by parental behavior can impact nestlings' trajectory of nestlings' growth and survival. So up until now, or recently, I've been focused on negative side effect. I was trying to show how bad the stress is for the animals, or therefore for us as well. But as you probably know firsthand, that the same stressor may seem fine at the time, but not so great or very overwhelming at another. For example, I have a paper deadline. That itself wasn't too bad, I can handle it. But at the same time, I have a family emergency, and I just got an email saying that my proposal was not funded. And all of a sudden, the stress of trying to finish this paper by tomorrow sounds really daunting, right? And that sounds familiar, maybe? And this goes beyond perception. Our body's reaction to stress changes with what else is going on, also the past experience with that stressor, and severity of stress. And put this into a figure, it's true that as the stress level increases, then performance, like your performance on a memory task, would decrease. But this is only a part of the story, because if you have no stress at all or very, very mild stress, you actually perform not great either. So this is why I asked you at the beginning, how would you rate your stress level like? If you answered moderate, although not many people did, if you answered moderate, then that means that your stressor, the stressor that you experience, may be pushing you to do better than if you didn't have stress much at all. So I've been wondering about this relationship between stress and performance, and what are the physiological mechanisms that explain this relationship. And I had this sort of scattered thoughts for a long time, and actually one day I was sitting and listening to a seminar, and something hit me, and sort of those scattered thoughts sort of came into place. And we now have a working theory and trying to describe what's the physiological underpinning of this non-linear relationship. So we have a very preliminary data from trying to get at this. And this is an experiment that one of the graduate students, Alex Hoffman, is doing right now. And he answered this question: can we train birds to a stressor so that they can cope with the stressor better later on? To answer this question, he took a group of young zebra finches, divided into 2 groups, and he exposed half the group to heat stress. So by exposing them to mild heat for 28 days, and the other half was experienced the same sort of handling and all that procedure without the actual heat stress. When they grew up, he divided each group into 2. Half of them experienced short-term but high heat stress, and the other group experienced no stress at all. And to quantify how well the adults cope with the heat stress, he made a small incision on the skin and measured how fast it took them to heal that wound. And we expected that heat-conditioned, heat-stressed adults would heal wound as fast as control birds, because the heat conditioning would negate the negative effect of heat on wound healing. But it turns out that regardless of the conditioning status, the heat-stressed animals actually healed the wound faster than the control birds. Of course, this is a preliminary data, and we'll look into more about this. But this indicates that the heat stress experienced as an adult have a positive effect on wound healing. So, and right now, and the next step for us is to determine how stress hormone like corticosterone, stress proteins, and oxidative stress would explain this relationship between stress and performance. So I had pivotal moments as an undergraduate student, graduate student, postdoc, and a faculty, and that led me to a long-term project because something that I observed or something I heard really sparked my interest. So I have two take-home messages for you. One is especially to those of you who are going to be a next generation scientist, and this is to find topic or a phenomenon or area of research that you are really, really passionate about. It could be something that you're already working on or something that you read about, heard about, and then you wondered. When you find that question, you own it and go for it, and you will be the next successful scholar. The second message to you is not all stress is bad. Thinking that the moderate stresses actually can do you good, or that not stressing about stress can promote healthier lives. So none of the things that I mentioned, I couldn't have done it without help from my wonderful lab members, my mentors and colleagues, and my family. And I thank them all from the bottom of my heart, and thank you for listening.